Okay, in this video, we'll be learning about section 5.8, modeling using variation. So what we're going to talk about is direct variation and inverse variations, okay? So the first equation that we need to make sure that we pay attention to is the direct equation one here, y equals k to the x. And it's got x to the n. Well, they could square it, take square root of x, different mathematical properties applied to the x value, the input, that would result in output. So that's why they have it x to the n. So this varies directly, which means that if x goes up, y goes up, and if x goes down, y goes down. Now, the other complement to this would be the inverse variation, which means that things are inversely related, meaning if the x goes up, the y better go down. If the y goes up, x better go down. Okay, so they vary inversely. So the equation y equal k over x to the n. So sometimes we'll solve for k, which is the constant, and that's just x times y. Okay, so let's kind of jump into the first couple problems, because what we're going to start out with is writing equations, and then we'll turn around and then solve nice proportions, direct variation, or inverse variations. Okay, so this says it varies directly, so we are looking at, from a equation standpoint, we're looking at y equals kx, right? So we need to, if we're going to write the equation, we need to find k. The constant between this relationship between x and y has some multiplier, some constant proportionality. So we need to find it. So if we solve for k, that's k is just y over x, right? So we've got y is 10, x is 2, so k is equal to 5. And then our equation would be y equals 5x, right? So all we did was replace the k. All right, so it says y varies directly as x. There's nothing really happening to x. Now when we look at the other one, it says y varies directly as the square root of x. So when we're looking at this, it's y equals k square root of x. So if we're looking at k would just be y over the square root of x, right? So we have a x and we have a y, so let's substitute those in. Square root of 25. So I got 40 over 5, which is 8. So 8 is our k. All right, so when we do this, it'd be y equals 8 square root of x. That would be the equation, right? So we replaced k with 8 because that's what we solved for there. So that's what these first couple examples with the varies directly or varies inversely is going to be having us to do. Okay, so just kind of be aware of that, writing the equation. All right, so y varies inversely. Well, if it varies inversely, then this is the equation, y equals k over x. Okay, so, and it just, y is very inversely as x, so there's nothing that's happening to x. So if we solve for x right here, it's just kind of like multiplying both sides by x. Our k would be, I'm going to put x times y, right? Because if I multiply both sides by x, it makes x y over here. So if I do that, I have x is 6 and y is 3, so the k is equal to 18. So that gives me y equals 18 over x. And if we substitute that 6 in here, if we go 18 divided by 6, do we get 3? And we do, so we know that the equation is correct. So this is my final result here. All right, now let's look at another one. It says write an equation describing the relationship of the given variables. Y varies inversely, right, as the square of x. So if it varies inversely, we've got y equals k over x squared, right? We know that we're going to take the x squared, move it up here beside the y to get the k, right? So what that's going to give me is 1 times 5 squared, which would be 25. That's what k equals, okay? So that's going to equal y equals 25 over x squared. And if we check it, we see that we have an x that is 5. So if I were to put 5 in here for x and square it, 25 over 25 equaled, guess who? 1. So we know that this equation is the equation that would give this relationship, this inverse relationship, okay? So that's what these ones are asking in the very beginning. All right, so we got another one. Y varies inversely, right, with the square root of x. See that square root of x? So we know it's inverse. So we know y equals k over the square root of x, right? So if we knowing that, then we can say k is equal to y times the square root of x, right? Because if I multiply both sides by square root of x, that cancels here and leave me with just k, right? What that's going to equal is this. 6 times the square root of 16. Well, we know that 6, that would be really 6 times 4, which is, guess what? 24, right? So if we write this equation, it's really 24 over the square root of x, okay? So, and that's our answer. Now we're going to check it, okay? We're going to plug 16 in for x, so the square root of 16 is 4. 24 divided by 4 is, guess what? 6, right? Okay. Now, that should be all of the writing equations. So we've done inverse variations, we've done direct variations. And you need to read them. That's the key words. Varies directly or varies inversely to be able to figure out what equation that you're using. Now, now we're going to be given a condition, x and y, and at least one of the other conditions, right? And asked to solve the other. And so I like to set these up as a nice little proportion. So it says y varies directly with x. So if you remember, here's the equation, right? Y equals kx, right? So if I were to kind of solve for k like we did before, it would be y over x. That would be k, right? And if we set it y equal x, now we got a nice little proportion. So what we're going to do is we're going to take this scenario and put 10 over negative 2 is equal to y over negative 4. And when we solve this, we get cross multiplied, right? Cross multiply. So that would be negative 40 equals negative 2y divided by negative 2. So y is equal to 20, right? And we can check it. So if we do this, if we substitute right back in here 20, let's see this side over here. This should be our k, and then if we do this one, this one should be our k, and our k should be equal to one another. So this 10 divided by negative 2 equal 5, and this 20 divided by negative 4 equal negative 5, and it does, right? So this checks out. So this little bit right here is kind of checking it back in, but they just wanted to know what would y be. Okay, so I set up a nice little proportion because this is what it would be if it varies directly, if we're given one and asked for, and one part of the other and asked for the missing term. So I set up a nice little proportion. Here's my check, right? I'm kind of checking it right here. This is what this is, right? Just kind of verifying negative 5 and negative 5. Okay, I got my answers correct. Now let's go look at the other one. Y varies directly with the square of x. Again, I always start out y equals kx, so my y over x equals y over x, right? Because it varies directly. Now, let's go ahead and substitute. I've got negative 48 when I have an x of 4, and then I have a 3 here. Not a 3, I just put x. I need to actually put 3. Okay, so my k here would be negative 12, right? So when I solve for y, when I plug it back in, just to verify, does it equal negative 12? Then it, that's what we're shooting for. So here we go. Negative 48 times 3. Let me do that again. Negative 48 divided by 3. Not divided by 3. Sorry, apologize. That'd be negative 48 times 3. Negative 48 times 3. Sorry. That would be negative 144 equals 4y. And then divide by 4. So so let's divide by 4. So that would be negative 36 is equal to y. Okay, so if we plug this in and put negative 36, does negative 36 divided by 3 give me negative 12? And yes, it does. So my answer, it just said, what is y? So y is negative 36. But I verified it that my y that I calculated was correct. And I've done that right here, right? By looking at this fraction, negative 36, making sure I have a k equal to a k. All right, so let's do another one. All right, so now we're switching gears. We just did direct solving. Here's 2 scenarios, solve for the missing term. So we're going to do inverse, and I really like inverses because it's y varies inverse with the square of x, right? Square of x. So what I start out with, I go y equals k over x squared, right? So my k is going to be x squared times y equals x squared times y. Okay, that's what my k is going to be equal to. If I look at this, I have 8 squared times 8 equal to negative 5 squared times y. So if I look at this, here's my k. What does that give me? So let's see. Probably ought to give me 256, but 8 squared is 64 times 8 should be, no, 512. My apologies. So that's 512 equals, yeah, equals 225y. So if we're doing this and we divide by 25, let's see, divide by 25, and that gives me a fraction, and I don't need a fraction. Hold up, let's see something. Okay, so I just kind of set up the equations right here. Y equals k over x squared in there. Let me move this. Our x was 8, so I got y is equal to 8, so I know that that checked out. And when I did this one, it's 512 over x squared, which is 25, is 20.48. So when they say they want y, they want 512 over 25, because that's really what y equals, right? Y equals 512 over 25, which is 20.48. But they're probably going to want that as a fraction. So put it as a fraction. All right. I want to go back one. And here, I'll let you see that for just a little bit longer. I just verified that what I got out, because I got I got a fraction, a decimal didn't come out to be a nice pretty number. I wanted to stop and make sure that what I got and double check everything. So that's, that what I just did over here to the left and then over here to the right are things that you can do to verify that what you got, if you got something that's kind of looks crazy or whatnot, you can verify. I want to go back to this one. It says the square of x, and I just messed it up, folks. So let me redo this. So I back up one problem. I didn't say the square of x, and I need to work it correctly. So let me, in my haste, yeah, I want to make sure, yeah. So I just didn't put it as a square, and I think just, I don't know, I need to slow down. So negative 48 over 4 squared equals y over 3 squared. Well, what that's going to give us is negative 48 over 16, right, equals y over 9. And then negative 48 times 9, if you cross multiply, is negative 432 equals 16y. And then, of course, divide by 16. Then we get negative 27 is equal to y, right? So we got negative 27. So I want to check it real quick. I want to do the k over. So let's do this. This would be, do this is negative 48 over 16. So my k here would be 3. And if I go, my y was negative 27 on this, and 3 squared is 9. So that would be k equal to negative 3. So again, that checks out. So I know that what my answer was is correct. So if you caught it while I initially went through and said, oh man, Palmer missed this, then know that I corrected it right there, okay? There's that one. Now let's do the last one here. Y varies with inversely with the cube of x, right? So the cube of x. So I got y equals kx, right? So inversely would mean that, yeah, x cubed. So I just, my thought straight there. Y is inversely is the cube of x, not the cube, or the cube. So x cubed. Okay, so I get x cubed times y equal to x cubed times y. Well, don't fret over this because you got fractions. It comes out to be a nice little thing. So 1/2 raised to the third power times 32 is equal to 1/4 raised to the third power y. So this would be 1/8 times 32, and this would be 4 times 4, 16. It'd be 1 over 48 y, right? So if you look at this, 32 divided by 8 is 4, so that's really y over 48 here. If you were to do this way, you know, multiply these two together, it'd be y. So I would just multiply both sides by 48, and when I do that, I should get 48 times 4, which is 192. So 192 is what my y is equal to. Okay, so let's check it, just to kind of verify. I want to make sure. K should be equal to x cubed times y, right? So let's take 1/2 cubed times 32. We know that's 1/8 times 32, which is equal to 4. Okay, let's do the other one. Let's check the other one. 1/4 cubed, and we said this was 192 times 192, so this would be 1 over 64 times 192. So basically 192 divided by 16, and I get 12. Okay, so let me, 4 times 4 times 4 is 64. Where did I go wrong? Reciprocal of that, 48 times 4. Did I do that wrong? Geez, here's my problem. Okay, time out. I gotta fix I made a calculation mistake right here. It's not 48. Slow down, Palmer. It's a long day. So 4 times 4 times 4 is 64. So let's put in 64. So if I multiply everything by 64, so 64 times 4 is 256, right? So let's do this. Let's erase this. Let's make this 256, and 256 divided by 64 is 4. All right, so let's go back up and make sure I corrected that. So 256 is what y has to be, right? All right, so there. Just be careful. These solving things, if you're working a bunch of them together, write the formulas down. Double check your work, because I've made 2 computational errors just in this video. Now I went back and corrected them. But if I'm likely to make mistakes when doing this stuff, then you probably are as well. So just say, oh, I'm checking these, making sure that it comes out to be 4. If it didn't, then I know my answer is wrong, right? So that's just a good mathematical principle of just verifying what you're doing. All right, so I think that is it. So here's this one, 256. Inversely with the cube of x, write that down. And then, of course, here's this one that we checked out. And then this one over here that I missed the x squares, right? I missed that. And then went back and reworked it and found it. And double checked everything. So, don't ask me why well, I do know why my k's come out to be the same, but it would have been a wrong y, which was the problem there. So, okay. So that is the end of 5.8.